Okay, so for this video, I'm just going to do the chapter 3 problems that I haven't recorded yet. I have 2 previous recordings that have some selected problems from chapter 3. Okay, so go back to those videos. So here we have an exponential with base e. The h is minus 4 and the a is 2. So you see above in red, above the reference points, how the reference points are going to be changed. So we're going to have 0 minus 4 and 2 times 1. And then 1 minus 4 and 2 times e, so 2e. So it's approximately, since e is 2.71828 and it goes on, 2e is approximately 5.4. Okay? And horizontal asymptote, since k is 0, it's going to be y equals 0. Alright, so here's the graph. First, I'll draw the y equals 0, the asymptote. So that would go about here. Okay, and then the points, -4, 2, and -3, 5.4. So that would be about here. Okay, so remember, it's not a line, it's a curve, an exponential curve, and it's going to be very steep. So it starts off almost 0, and it keeps going. And if you wanted to see where across the y-axis, because it will, remember the y-axis is not an asymptote. It only has a horizontal asymptote, not a vertical. So to see what the y-intercept is going to be, replace the x with 0, so it'd be 2 e to the 0 plus 4, which is 2 e to the 4th. So you plug that into a calculator, and that would give you the number. It's going to be a very big number. Okay, so you put that into a calculator, it'd be about 109.2. So that's where it's going to touch, it's going to cross the y-axis at this value. So it's way off of our graph. Alright, so on 63, since the bases are the same, then we can say that the exponents have to be equal. So this equation leads us to x squared plus 10 equals 7x. So we move the 7x over to the other side, and that gives, and put it in standard form, x squared minus 7x plus 10 equals 0. So factors of 10 that add up to -7 would be -5 and -2, so this becomes x minus 5 and x minus 2. So then x equals 5 and 2, or 2, 5, however you want to write it. Alright, so for this problem, the bases are not the same. I have a 3 on one side and a 9 on the other. So first thing I try to do is see if I can get common bases, and in this problem I can. So plus 9 equals 3 squared. So now that I've set the bases equal to each other, I can say that the exponents are equal to each other. Subtract 9, so that gives me -7. Divide by 5, so that gives me -7/5. Alright, so 65 is similar to 64, that the bases are not the same, but I know, and you should know, that 3 to the 4th power is 81. But again, so let me write that first. 1/3 to the 5x minus 2 is equal to 3 to the 4th, but the bases are still not the same. So if I switch 3 on the right side to 1/3, which you can do, that would make the 4 a -4. Okay? Now I could set the exponents equal to each other. So 5x minus 2 equals -4. Add 2 to both sides, and then divide by 5. And that would be the answer. Okay, so first we want to isolate the base with the exponent. So we add 32 to both sides. So that leaves you with 4 to the x plus 4. You add 32 to both sides, so the right side becomes 16, because 32 minus 16 is 16. Bases are not the same, but with 16 you could write it as base 4. So that's 4 squared. Now that the bases are the same, now we could say the exponents are the same. are equal to each other. So subtract 4 from both sides and you get negative 2. Okay, so for part A, you have to change from logarithmic form to exponential. There's no computation to do here, it's just changing the form. So the base is 9, the exponent is 3, and that equals 729. And that's it. On letter B, I had to add equals x because it wasn't an equation on the worksheet, so I just made it equal to x. So this becomes, when you see ln, the base is e, the exponent is x, and it equals 8. And again, that's all it is, changing from logarithmic to exponential. Alright, so 71, I skipped to 71 because I have 68 through 70 in another recording. So for A, log base 5 of 125, what they're asking you is, what's the exponent of 5 that would give you 125? So 5 to what power is 125? And the answer to that is 3. For B, e to the ln x squared, remember when the base and the log and the exponent are equal, the base and the exponent of that log, then it just equals whatever follows the log. So in this case, it's x squared. Letter C, 5 to what power is 1? 5 to the 0. And D was a typo, that 125 had to be next to the log, not down with the 5. So it should look like I have it on the screen. So remember, when this base matches this log, the answer is just what follows a log, 125. And I showed you in class why that's the case, okay? But if you need to ask about that again, you could ask me in class. Alright, so first you want to isolate the base with the exponent, so I'm going to divide by 2, both sides, so that gives me 3 to the 6 minus x equals 4, because I divided by 2 on both sides. I can't get the 4 to a base 3. Okay, so when that happens, you have to use logs. So I just like changing the base. I mean, not changing the base, changing the form. So you write this exponential as log base 3 of 4 equals the exponent. And so now I'm going to subtract 6 from both sides. So negative 6 equals negative x. I'm going to multiply by negative 1. So that leaves me with 6 minus log base 3 of 4 equals x, because I multiplied both sides by negative 1. And so now this would be the exact answer. I'm going to use the change of base formula. And so, oops, why did I add an extra like that? So 6 minus log 4 divided by log 3. So you just punch this into the calculator and you get approximately, okay, so when you put this into the calculator, you get approximately this value right here. Alright, so for 81, you want to isolate the natural log x. First thing we're going to subtract is 6 from both sides. So I'm left with 3 ln x equals 1 minus 6 is negative 5. Then we divide by 3. So I get natural log of x equals negative 5 over 3. Okay, so you change the form at this point, and so that would give you e to the negative 5/3 equals x. So that would be the exact value. You plug it into a calculator and you get this. Excuse me. Alright, so for 82, this is a formula we're going to use, and it says that you're starting off with 97,500 and it grows at an annual interest of 4.4% compounded continuously. How long will it take to double the investment? So whenever they ask you a question like that, double or triple, like that, you don't even care what the initial amount is, because whatever this is going to be twice as much, right? So it's going to look like this. So when you isolate the e to the exponent, you divide by p, and so you're going to be left with 2 equals e to the RT. Okay, because it's doubling. So it doesn't matter if you start with $5, $1,000, or $97,500. When you double it, this is what it's going to look like. So I'll put 2 equals E. The rate is 4 4/10%. So it's going to be 0.044. So let me like that. And we want the time for that to happen. So I'm just going to change the form. Base is E, so I'm going to write natural log of 2 equals the exponent. I want t by itself. So this would be my exact value. Okay, but I need to plug it into a calculator, and I get approximately about 15.8 years. Okay, so here's another doubling problem, right? You start with 75,500, it doubles in 7.5 years. So it's going to be 2 equals E to the RT, so 7.5. Okay, so natural log of 2 equals the exponent, so I'll put the 7.5 first, divided by 7.5. So again, this is the exact value, but the rate is approximately, plug it into a calculator, and you get 0.092, right? So you're going to move it 2 places to the right, so that's 9.2%.